Hello everyone and welcome back to the Leetcode grind. Today we have 78 subsets where we're given an integer array nums containing unique elements from which we are to return all the possible subsets. It does say here that the solution set must not contain duplicate subsets, and all that means is that if we have a subset 1, 2, a subset of 2 comma 1 is equivalent to 1, 2. So the order within the subset does not matter. It's still counted as the same subset, or rather duplicate subsets. And then we can return the solution in any order, meaning that the individual subsets themselves like these may be out of order. This 1 comma 2 can be returned here, or at the beginning, or at the end, something like that. All right. And also note that whatever the input is, so here for these two, they all start with an empty subset. And then starting from that empty subset, it looks to explore every possible next number. And then from that next level, it explores every possible next number after that. So after 1, there's 2, and 1 dash 3, and so on. So if we bring over the input here, we have nums, which is equal to 1 comma 2 comma 3. Okay, and we always start empty. So this is our first result. We're adding this into our first result. Once we do that, then we can explore down the next possible number to add. So we can take the number at the 0 index, which is 1. So carry down whatever is the incoming path, which just happens to be empty, add the current index number, the next number that we want to add. And then once we have this, we add it immediately to the results. And then we're going to see what's the next number that we can add. Well, the next number that we can add is 2. So it can be 1 comma 2. Because we're carrying down whatever is the incoming path and adding whatever is the next number under consideration. Okay, and then can we go down this further? Well, we can. There's another number we haven't considered, so that's 1 comma 2 as the one that's being carried down from the previous level, and then we can explore the last number, which is 3, and we can add that to the result. Okay, so now in terms of backtracking, what we do is we basically complete this. There are no other numbers to consider, so we backtrack out of there, we come back up, and then we go back up once again, and then say, okay, so let's pretend that, we've used up, so we're here, right? We've used up 2. Let's backtrack, as in let's remove that guy. Let's remove the 2, and we're back at 1 right here. So we here technically remove the 3. Here we remove the 2, and we're back at 1. Now here, if we don't consider 2, is there another number that we can consider? Yes, there's 3. So let's do 1 comma 3, and immediately add that to our result. And then let's go further down if we can. Now we can try, but there's no other numbers to consider. So let's backtrack out of there, meaning let's pop off the 3. We're back here. And when we're back here, we've explored all the paths here. So we pop off this guy. We're back to here. We're back to the empty state. Okay, so what if we had skipped the 1? What other number could we have explored? Well, there's 2. So let's do that. Once we're at 2, remember, whatever new path we form, we immediately add to the result as a valid subset. After this, is there another number we can consider? Yes, there is. There's 3. So carry down whatever is the incoming path and add the next number that we're considering, which is 3. Immediately add it to the result. And that is the last number, so there's no other numbers to consider. We can backtrack out of there, meaning we pop off the 3, we're back at 2. Once we're at 2, there's no other paths to consider, so we pop off the 2, we're back at empty state. And now let's see, if we had skipped the 1 and the 2, if we had skipped the numbers at index 0 and 1, what do we have? We still have index 2, which contains value 3. So let's do that. Let's add the 3. Okay, and then once we form a new subset, we immediately add it to the result and try to explore further. However, that is the last number. There's nothing else to explore. We're gonna pop off this guy, and then there's nothing else to pop. We're done. We dug deep, and then we're back out, and the function is done. So let's carry this over into code. We'll call it DFS because it's shorter, and that we always had a start index, the start of the range of exploring indexes. And then we had some path that we also started with. Okay, and then whatever path we had, first we added to the result. So let's declare that down here. We have result, which we're going to return after we call DFS starting from the first index and starting with an empty array. Okay? And once we are here, remember we first add that path to result. Once we do that, we explore every other or every next number that we can possibly add. So for I in range, from start to the length of the input array nums, right? So n, we're going to call it self. We're going to just DFS once again in further, but we're going to explore the next index. So here's the start index. So let's say the start index is 0. We consider every other number. Okay, let's just do this code. So we're going to do I plus 1. And then for the path, what we're passing in is whatever we received, we're going to add to it another list. We're going to combine these two lists, and this list being nums at the current number. Okay, so this part's confusing, but this, do remember DFS, we're calling that with the start of whatever is the next level, right? Because the number at I is being integrated to the path, and the combined path is what we're passing down. So when we're passing down, we're passing the next index that we wanted to consider. And so if we run through this example here, we see that we start from 0 with an empty path. And then we first immediately add whatever is the incoming path. Here it's empty. Let's add that. And then we start from that index. So I is equal to 0. But what we pass in for the next level, so this is the current level, this is the next level. The next level, we're passing in whatever is the incoming path plus the number that we are considering. And this can be 0, 1, or 2 because this happens to be the length of 3 and this is exclusive. But currently we're exploring 0. So let's worry about 0. 0 has 1. So we're passing down this. This is our path. And the index we want to consider in the next iteration is not the current index, it's the next index. So it's 0 plus 1, that's 1. Okay? So now let's say that we're here and we're going to add that incoming path first of all. Let's not forget. And then we're going to start from that index and say, well, now we know, right? We're going to pass in the next index. So 1 plus 1 is 2. But then the path is whatever is incoming, which is this, plus whatever is the current number. I is 1, the current number at index 1 is 2. So we're passing in this. And we're, once again, DFSing into this with these parameters. Let's get that. Okay, and then we, first of all, immediately add this as a valid result. And we start from 2, same here. But then when we DFS, we pass in the arguments for the next level. So it'll not be the current level, which is 2, it'll be the next level, so that's 3, with the path, which is the incoming path, plus the number at the current level. The current level I equals 2, index 2 contains 3, let's add that. And this is what we're passing in to our DFS function. So let's carry that over. We're here now. We add this immediately to our result, and we start at I equals 3. But note here that the length is 3, and n, this part is exclusive. The end is exclusive, so we don't execute these 2 lines, and we just exit out. So this is essentially where we pop off. We're backtracking. We're going here. We're down here. This is 0, 1, 2. There's nothing at index 3. There's nothing else to explore. So we're backtracking. We're going back up. We're going back up here. Now, when we're up here, we have, what's the state? We have the current path being 1, and we had gone down the path of 2, but now we're going to go down the path of 3. So this will be index 1, right? Where we had gone down path of 2, but we're going to try another path. So at this point, we had just added 1. Now we did all that other stuff, but instead of starting from 1, right, we're going to do 2. We're going to skip the 1. We're going to skip this guy. We're going to skip this guy. Or we backtrack out of there. We're going to do the next one. So that's going to be 2, which means we're going to next consider the next index. So 2 plus 1 is 3. And then it's the incoming path plus the number at the current index. The number at the current index of 2 is 3. Let's add that. Okay. So and then DFS into this. And you'll note we first add the path over here. Okay. Now, index I is 3. Well, that's the end. This is exclusive, so we're done. We backtrack. We pop off this guy. We're out of here, and then we're back here, but we've explored all the indices. 2 and 3, that's the end. There's nothing else to explore, so we're actually going all the way back up here. We're popping off the 1 as we're all the way going back up here. So the state is currently 0 with an empty path. And we're actually here where we had explored where I is 0. That was down the path of 1. We had explored where I is 2, I is 1 with the value 2 at that index. Now we're going to explore 2, where the I is 2. Okay, so when I is 2, the next index that we'll consider is 3, right? And then to the current path is empty. Once again, we had popped off of everything. The current path is empty once again. So we're going to add, oh, we haven't explored 2 yet. Okay, we had explored 1. Let's explore 2, or index 1, which contains the value 2. Okay, so now I is 1, which has 2. So let's add that, which means this is actually going to be 2. And then this is the incoming path. We add to it the current number. The current number is 2. And we DFS into this. Here we go. We add that to our results. And then start the I at the incoming I. But then when we DFS, we're going to consider the next position. And whatever is the incoming path into it, we're adding the current number at index I, which is 3. So let's add 3. We're DFSing into this with that. We're adding this as a result. And I starts at 3. The end is 3. We pop out of here. And so we're done with this entire side. We've popped off this, this, and now we're back here once again. Okay? So once again, the start is 0 and the incoming was an empty array. We've explored the path of index 0 and index 1. Now we're going to explore the path of index 2. So I is equal to 2. And we're going to DFS into the next index, which is 3, with the incoming path, which is that, plus the current number at that current index. So at index 2, it's 3, so we add that. And we're going to DFS into this. Once we do that, once again, we always add the path to the result. And here we go. And I is once again a 3. And once again, it's reached the end, so we don't execute this. And we pop out of this guy. We're back here. We've done all the exploring we can from this guy. And we're done. We are done. Let's give that a go. And a submit. And there you have it. I hope this was helpful. This one was a little tricky to grasp. So it was a bit granular, but once again, this is 78 subsets. Thanks so much. Hope to see you next time.